While the crew continues its work, we'll take opportunity now to welcome Cheryl Malloy to the International Space Station Flight Control Room. Cheryl's on a phone, but she's located down at the Kennedy Space Center in Florida. Cheryl, welcome.
Thank you, Kyle. It's a pleasure to be here. I wish I'd have been able to squeeze in a trip down to Houston to be in the control room with you.
Well, next time we'll hopefully get you here. Cheryl is a partner manager for the for United Launch Alliance, one of the 7 partners in the Commercial Crew Program, and we wanted to take an opportunity to talk to all 7. And Cheryl will close out our week. And Cheryl, I always start with a little biographical information. So tell us all about yourself, where you grew up, and how you got to NASA.
Oh, okay. I was born and raised on Florida's Space Coast, so I've been watching rockets launch from my backyard all my life. My parents both worked for NASA during the Apollo era, so that sort of makes me a second-generation space baby. I like to tell folks I've been at NASA forever, and I think you got a picture as my proof there. Most folks assume that I just followed naturally in my parents' footsteps, but that's not quite the case. I went to the local community college, Brevard Community College, and graduated as a medical lab technician and worked in the local hospital for a while. And then I decided I wanted to be an electrical engineer, and I didn't know it at the time, but that's pretty much a natural step for med techs. I went to Florida Tech, which is used to be Florida Institute of Technology, and while I was there, I co-opted with NASA's biomedical engineering group, and that sort of blended both experiences really well. And after I graduated, NASA offered me a job working life science space lab missions. You remember space labs?
Yep, absolutely.
Yeah, my favorite was Space Lab Japan, working with their Japanese life science teams. That was a great opportunity. NASA's also provided me an opportunity to go to school at night and earn my master's in engineering management from the University of Central Florida. And just recently, I've got a certificate in space systems engineering from the Stevens Institute of Technology. And I think just, learning is just a part of NASA's culture.
Yeah, no kidding. So, that's how you got here. But what did you do before you joined the Commercial Crew Program?
After Space Labs, I actually moved over to the Launch Services Program. They moved that program down here to the Kennedy Space Center, and I helped start that program here. And I had the opportunity to lead teams launching NASA missions on expendable launch vehicles, including those from ULA. So that's where the relationship started being built with ULA. And LSP offered me a whole range of opportunities, from being responsible for sending teams downrange to Africa and Australia to capture downrange telemetry, and also doing the first orbital mission from the Kodiak Launch Complex in Alaska.
Wow, that's pretty impressive.
It's a wide range for sure.
No kidding. Well, talk to us a little bit about your role now as a partner manager. What do you do as a partner manager for ULA, and what is your role?
Partner manager sounds like a dream job, doesn't it? I'm going to go out and manage partners, and that is so not the case. First and foremost, we're partners with ULA. I serve as an interface between our pit crew. I think you've talked about that. Our teams are partner integration teams, and ULA, and we foster a good relationship. We foster collaboration in areas where we have experience that they might be looking for. We're trying to break down barriers and facilitate an understanding of our understanding of what commercial means to them and their understanding of what human spaceflight means to us. And something I'm not sure you've heard too much about for the partner managers is we also advocate for our partners within the program. That sort of sounds like I've changed badges, but that's not the case. What the program needs to hear from the 7 partner managers is how decisions that they're making are affecting the partners, and the program gets a cross view of how those decisions may be impacting several partners. And so each of the partners does that advocacy back into the program and allows them to see how decisions could be affecting all of the partners.
You talked about the pit crew, and Ed Mango, you mentioned that earlier in the week. Is a pretty impressive group of people that you guys put together, to support you, I guess, in the role as a partner manager, right?
That's true. My pit crew, if I can brag on them for a minute, they are matrixed, and Ed did mention that. They're from Marshall and JSC. We've got some time from Langley and KSC, all together with the Launch Services Program as well. And they bring a wealth of experience both in human spaceflight and Atlas V experience, because, again, that's what the Launch Services Program is currently flying. And we've got folks that have worked Shuttle and Ares and 1X, and so all of that experience together allows them to gain an understanding back and forth, as well as share that data with United Launch Alliance.
Talk about the Space Act Agreement part of this. It's a new way of doing business, but how are you integrated with ULA?
Ed did mention earlier in the week that there were 4 fundeds and 3 unfundeds, and ULA is an unfunded. We are further along in the technology. Ed was talking about the fundeds went to development risk areas, and United Launch Alliance has 29 successful Atlas V launches already. They've been flying that heritage vehicle for a very long time, and although it's not suitable for human spaceflight right now, all of that data and technology has allowed ULA to gain confidence in their vehicle, so they really know how it operates. And that will allow them to make the unique accommodations that are required to human spaceflight. It'll allow them to do that better with the understanding of how their vehicle already flies.
I know I'm going to jump around a little bit because we've only got about 5 more minutes or so, but
okay.
I know you had a video that you asked us to prepare for you. If this is a good time, I'd like for you to either show that or talk to it for us, if you don't mind.
Sure. If you want to go ahead and play it, I'll talk to it. And what I'm showing you, and actually it starts with an Atlas V launch and processing, and those always get your blood going. But one of the design modifications that ULA will require is an emergency detection system, and they've already done some work on this. ULA developed a prototype of the emergency detection system and the processor and the software that are going to be required to monitor the launch vehicle. So in using this vehicle for human spaceflight, you've got to also have the ability to board the crew in case something's going wrong with the vehicle or the spacecraft. So what you're watching is just some interaction between my team and the ULA team on looking at the software and the algorithms and doing the bottoms-up review on how those failures might be detected, which sensors you would be looking at, and what is a backup corroboration sensor that would say, yeah, the tank pressure might be falling, are we losing acceleration, those types of measurements. And after they've done an extensive review of the software, we actually took it to the SIL lab, or the Software Integration Lab, which is a high-fidelity laboratory, and demonstrated with hardware that the emergency detection software was doing what it was supposed to. And what's really important about this is you want to be able to do 2 things with an emergency detection system. You want to be able to get off a rocket that's got an issue, or a spacecraft that's got an issue, and you want to be really, really sure you don't get off a bad rocket. So you want to be able to do that in both directions. You want that detection system to work just right.
Well, you probably touched on it in your video, but with a couple minutes we have left, can you talk about some of the milestones that ULA has accomplished thus far and what's ahead of them?
Okay. So last September they did a design equivalency review. That's where ULA decided that they would do their own evaluation of the design they're flying against the Commercial Crew Program's 1100 series. So that allowed them to see if there were gaps in where they would need to do something different with the Atlas V. And that started the conversations between our team and their team on what would meet the intent and what would be acceptable for human spaceflight. They finished that review with a tailored systems requirements review in December of 2011. And it came down to 4 major areas that would require modifications to fly humans. One was the emergency detection system that you've already heard about. They're going to do what's called a managed flight profile for structural reasons. One thing we don't think too much about is that this vehicle will launch from Launch Complex 41, and that has no way to get the crew in or out at this point, or an egress system, so that's one of the ones that is kind of obvious. And then they're going to look at a dual-engine Centaur, which will improve the capability of the vehicle. So those are 4 main things that we're working on right now, and they're evaluating and doing the testing on that. So their upcoming systems requirements review in mid-June will report out on how they're doing in developing those designs.
And it's just a tremendous amount of work, and I think you've laid that out beautifully in the time we have here. And I really appreciate you taking the time. In fact, all of the commercial crew program experts that joined us all week. But that was a great way of wrapping up the week, Cheryl, and we appreciate you joining us here in Mission Control.
Oh, well, thanks very much for having me.
Thanks again. That was Cheryl Malloy, the Commercial Crew Programs Partner Manager for United Launch Alliance, one of the 7 partners involved in the Commercial Crew Program.